Have you ever just stopped and wondered how our digital world got so complex? I mean, everything from your banking app to the dashboard in your car, it's all running on these massive, intricate pieces of software. Today, we're going to explore the revolutionary shift in thinking that actually made all of it possible. And that's really the big question, right? As our ambitions for software just got bigger and bigger, the very methods used to build it, well, they just started to break. Developers were facing a true crisis of complexity, kind of like a digital Tower of Babel. So how did they solve it?
Okay, so to really get the solution, we first have to understand the problem. So let's wind the clock back a bit, back to the 1980s, when programming was facing a massive challenge.
You see, in the 70s, programming techniques were fine for what they were being used for. But just a decade later, the world wanted so much more. Software was getting bigger, way more powerful, and a whole lot more complicated. The old ways of building things were being stretched to their absolute limits.
So how did we even get to this breaking point? Well, a quick look at the timeline of programming shows this constant evolution that was honestly struggling to keep up.
It all started with the absolute basics, machine language. Then came what's called the procedural approach, with languages like Fortran, which let programmers write code like a recipe, just a sequence of steps. A big leap forward was structured programming, using languages like C, which was all about organizing code into cleaner modules and functions. Each step was an improvement for sure, but by the 1980s, even this just wasn't enough. A totally new approach was desperately needed.
And that new approach, well, it was a complete paradigm shift. A revolutionary idea called object-oriented programming, or, as you'll usually hear it called, OOP.
This image here really visualizes the problem with the old way, with structured programming. You've got a main program, and it's calling all these different functions. Now, for small projects, this works. But as programs grew, the connections just became a tangled, confusing web. You change one little thing over here, and it could unexpectedly break something completely different over there. It was a nightmare.
And here's the aha moment. On the left, that's the tangled web we just saw. But look at the right. That's the object-oriented approach. Instead of that mess of interconnected functions, you have these neat, self-contained objects. It's a fundamentally cleaner and just more intuitive way to write code.
So the crucial point is this. Object-oriented programming organizes software around these objects. Think of them as little independent machines. Each object contains its own data and the functions it needs to work with that data. They're totally self-contained, which makes the whole system much easier to manage.
You know, here's probably the best analogy to understand this. A class is like a blueprint for a car. It defines what a car is. You know, it has wheels, an engine, a color. Then, use that blueprint to build the actual objects, a green Polo, a blue Mini, a red Beetle. Each one is a unique car, but they all follow that same fundamental blueprint.
This new approach also came with a massive security benefit. In the old model, data was often just exposed, kind of like an open box that any part of the program could just reach into and mess up. OOP introduced data hiding, which essentially locks that box. An object's important data is protected, and it can only be accessed through approved, safe methods. This was a total game changer for building reliable applications.
Now, the idea of OOP was brilliant, but it needed a champion to take it mainstream, a language designed from the ground up to make it easy and powerful. That champion was Java.
So in 1995, a company called Sun Microsystems released Java. And unlike other languages that had OOP features kind of tacked on as an afterthought, Java was designed from the very start, from its very core, to be purely object-oriented.
And it came with this incredible killer promise: write once, run anywhere. You have to understand, before Java, if you wrote a program for Windows, you had to completely rewrite it to run on a Mac. Java promised to end all of that. You could write your code one single time, and it would just work everywhere. So how did they pull this off? It's actually a really clever three-step process. First, your source code is compiled not into machine-specific instructions, but into this universal format called bytecode. Then, on any device, there's a piece of software called the Java Virtual Machine, or JVM, that acts like a universal translator and interprets that bytecode. And just like that, boom, the program runs, whether it's on your computer, your phone, or some giant server. Beyond that killer feature, Java was also super robust, catching errors that other languages would miss. It had security baked right in. It was also multi-threaded, which is just a fancy way of saying it could easily handle multiple tasks at once, like downloading a file while you're still typing. and it simplified some of the really difficult, really tricky parts of older languages like C++.
So what was the result? What happens when you combine that powerful OOP philosophy with the accessible Java language? Well, let's look at the massive impact it's had on all of our lives.
I mean, the reach has been just staggering. From the massive enterprise systems that run our banks, to the server-side applications that power a huge chunk of the internet, to mobile apps, especially in the early days and of course with Android, Java is simply everywhere. It's the invisible backbone of so much of our modern digital world. So in the end, a new way of thinking, a new paradigm, solved the software crisis of its day and unleashed decades of innovation. And that leaves us with a final thought, doesn't it? As we face the incredible complexity of today's AI and massive data systems, what's going to be the next object-oriented programming? What's the next big idea that will